This past April, temperatures in cities like Delhi and parts of Rajasthan breached 40, even 50 degrees Celsius. It got so hot that crayons left outside began melting into brightly colored puddles. Meteorological models from the ECMWF indicate that the extreme conditions of 2024 were essentially a test run. The actual anomaly, a much larger, more dangerous oceanic event, is projected to hit its peak in the summer of 2026. To understand the scale of what is forming, we have to look at the year 1877. A similar global weather disruption erased the winter season in parts of the US and triggered widespread crop failures. Millions of people starved across India, China, and Brazil. That 19th century disaster was driven entirely by a natural cycle. When that exact same cycle returns in 2026, it will strike a planet with far fewer forests and a much hotter atmosphere. This diagram illustrates the normal state of the Pacific Ocean. Notice the blue, cooler water along South America and the red, warmer water near Australia. These arrows represent the trade winds blowing east to west, constantly pushing that warm surface water toward Asia and allowing cold, nutrient-rich water to rise up near Peru. But every few years, those trade winds lose their strength. Without that continuous push, the warm water pools backward across the entire central and eastern Pacific. Meteorologists call this phase El Niño. Because evaporation from that massive warm water pool dictates where rain falls, shifting it to the middle of the ocean robs surrounding landmasses of their usual moisture. You can see the result here. Severe heat and dryness immediately lock in over Australia, Southeast Asia, and India. The current forecast predicts a 61% chance of an El Niño forming by mid-2026. Models suggest ocean temperatures could spike by up to 2 degrees Celsius, classifying this as a super El Niño, exactly when India's monsoon rains are supposed to peak. A 2-degree shift in a specific stretch of the Pacific Ocean, thousands of miles away, dictates whether farms in Maharashtra get rain or wither under the sun. Previous super El Niños operated on a relatively stable planetary baseline. Today, decades of industrial emissions have already pushed our starting temperature significantly higher. This chart demonstrates the math. Earth's baseline temperature sits 1.4 degrees Celsius above the pre-industrial average due to human activity. A strong El Niño adds another 1.5 degrees. Stacking this natural spike onto our elevated baseline pushes the planetary anomaly to an extreme 2.9 degrees. Imagine sitting in a closed room where the thermostat is already set to 40 degrees. Then someone walks in and plugs in a massive space heater. The original heat is still there. You are simply piling a new thermal shock on top of it. We are looking at a mathematical convergence that human physiology and modern infrastructure were quite literally not built to handle. The impact of this anomaly hits in distinct ways. First is the rainfall deficit. In a nation where 51% of all agriculture depends directly on monsoon rains, a failed wet season immediately halts crop production. That scarcity drives the second layer, economics. Historical data shows that during severe El Niño years, the collapse in crop yields causes global food inflation to spike by up to 9%. As rural economies buckle, the third layer takes hold across the cities. Scientists project the ambient heat waves of 2026 will easily surpass the grueling 50-degree days we recorded throughout 2024. But the peak daytime temperature isn't the primary cause of mortality. The true danger emerges when the sun sets and the ambient temperature stays above 30 degrees. Without that nightly cooling period, the human body cannot reset, causing the risk of fatal heat stroke to multiply rapidly. A shift in ocean currents destroys the harvest, driving up the cost of basic groceries, and trapping millions of people inside concrete cities that refuse to cool down. Those cities stay hot because we designed them to absorb radiation. By cutting down tree canopies and paving over soil with concrete, we've created urban heat islands. In 2024, Delhi's daytime temperatures increased by about 1.8 degrees, but its nighttime temperatures spiked by 4.4 degrees. To survive this, residents who can afford it rely on air conditioning. While the AC cools the interior of an apartment, the compressor pumps all that extracted heat directly into the street, actively raising the outside temperature for everyone else. The people forced to absorb that exhaust are India's 38 crore informal workers. Between buying extra water, purchasing medicine, and losing work hours to heat exhaustion, a street vendor or delivery driver can lose up to 40% of their daily earnings during a heat wave. Despite an estimated 1.5 lakh heat-related deaths annually, the government refuses to officially classify heat waves as a notified natural disaster. Doing so would legally obligate them to pay a 4 lakh rupee compensation to the family of every confirmed victim. The mechanisms we use to keep buildings comfortable actively endanger the workers outside, while the bureaucratic classification of the disaster ensures those deaths remain invisible. This split-screen diagram highlights the most effective, immediate solution we have. On the left, exposed concrete absorbs and radiates maximum heat. On the right, a mature tree canopy shades the pavement. Studies show that at the pedestrian level, this simple layer of shade can drop the temperature by a massive 12 degrees. Yet across the country, thousands of hectares of primary forests and centuries-old urban trees are being bulldozed to clear space for mining and highway expansions. Corporations claim they plant new saplings to replace what they cut, but research shows nearly 90% of those newly planted saplings die off, and the ones that survive cannot provide the ecological cooling power of a 100-year-old banyan tree. As long as 70% of the national grid relies on burning coal, these extreme thermal spikes will continue to compound. The 2026 Super El Niño will pass, but the temperatures it brings will quickly become the normal baseline. For children born today, the concept of a mild 35-degree summer simply does not exist. Their baseline starts at 45 degrees. Getting through the coming decades requires fighting to keep every mature tree in the ground, migrating our local power grids to solar, and preparing our communities for the heat that is already locked in.